But from here, R1 minus R2, which is this lies between strictly above minus n and strictly below plus n. Okay? And the right-hand side, that's a multiple of n. It's some integer times n. Okay? Now the only way, if you think about it, the only way that and that can be compatible is if this is naught. Right? So if this is naught, you could have this being naught. Right? N's not naught. Okay? Now I'll say it again. The right-hand side is a multiple of n. 1n, 2n, 3n, minus 1n, minus 2n, minus 3n. It's a multiple of n. Okay? Whereas this is strictly between minus n and n. Now the only way that and that can be compatible is if this difference is 0. Okay? And if that's the case, so that implies that R1 minus R2 is 0. And that implies that the two remainders are equal. And that completes the only if part. So we've done the if and the only if part, so we've proved it. Whew. Okay? Alright. Alright, now let's talk about conjugacy, or actually residue class. Now that's not too difficult, so we should be able to get through that fairly fast, so we don't have a 2-hour lecture. Because the reality is, living in China, my website is on WordPress, and WordPress is banned by the Chinese government, so I have to use a proxy server of some sort. So I use a VPN, a virtual private network, and they tend to be fairly slow, so it takes me about, well, during the day I can upload a 10-minute YouTube video in 3-4 hours during the day, and at night time, say very late at night, it'll be about half that. So I tend to chop up my videos into 10-minute clips. So a 2-hour lecture would then be 12 clips, and that's pretty well a day, a whole day of upload time, 24/7. So I'm constrained, my main constraint is the upload speed. So if I want to get out a lecture per day, which I'm trying to do, because I have so many to do, I'm trying to teach literally quite a few hundred courses in the next decade or two. So if I'm to do that, if you do the math, I have to churn them out. Alright. Okay, so the notion of a residue class, so that'll be the next topic, and we'll get through this fairly quickly because it's fairly easy. Alright. Take a number like 3. Now, its conjugate to 1 mod 2, right? Does that seem obvious? Because, that's your A, that's your B, and that's your N, and A minus B, so A minus B, so N divides A minus B if these two numbers are conjugate, by definition. Okay? So A minus B, so that's 3 minus 1, which is 2, and 2 divides that. So 3 and 1 are conjugate, mod 2, right? Now, how about 5? 5, is 5 conjugate to 1, mod 2? Is it? Well, you know, the usual trick, so 5 minus 1, so 2 divides that, because 5 1 minus 1 is just 4. Okay, now can you see where I'm going with this? So 3 is conjugate to 1, mod 2. 5 is conjugate to 1, mod 2. 7 is conjugate to 1, mod 2. Now, you see the pattern? So, so all odd integers are congruent mod 2. Okay? All the odd integers. Let's create a set of all these odd numbers. So I'll write it this way. Now they're all these odd numbers, they're all conjugate to 1. So I'll put a 1 in here and square brackets, and I'll put a 2 down here. So this is your remainder. Or residue. Same thing. Residue. Okay? And the 2 here is your n. Okay? Now what is this? It's the set of all these numbers that are congruent to 1. So it's the set, or maybe I should put capital letters, probably easier to read. So by definition, no, it's my use of the term, a bit confusing. So by definition, it's the set of all integers congruent to whatever's in here. In this case, it's a 1. Okay? Now I can rewrite. Now it's the odd numbers, right? It's 1, 3. So it's the set of all the integers that are congruent to what's in here. That's 1. So that's the same thing as 2z plus 1. Does that make sense? Right? Now what's z? Z is the set of all integers. So if you take all those numbers in that set, you multiply them by 2, and then add 1 to each of them, that will give you all the odd integers. Right? Make sense? Alright. So with that logic, what's this? What does that work out as? Now the number in here, that's your remainder. So let's try this. So is 2 conjugate? Now that means definition, and this means conjugate, right? Two different uses for the same symbol. Don't be confused. Now is 2 conjugate to 0 mod 2? Is that true? Well, 2 minus 0 is 2, and can you divide 2 into that 2? Oh, yes, that's okay. Now how about 4? Is 4 conjugate to 0 mod 2? Okay. So 4 minus 0 is still 4, and you can divide 4 by 2. So, and similarly, right? It's the same kind of trick, but this time we're dealing with the even numbers. Okay, so we can write down something similar to this. So so now what is this? Remember, it's the set of all your integers that are congruent to 0, congruent to the remainder. So this is your remainder, or residue. And it's all the even integers. So it's just 2z. Okay. Now, when your n, your modulus, when that's 2, you only have 2 of these possible sets, right? There's only 2, because integers are either even or odd. That's it. Okay. When your mod is, your n is 2, right? It's either that one or that one. All right. Let's try it now for 3 when n is 3. Let's see what happens. All right. So now we're going to have n as 3. Right? We're going to mod by 3. So